jumping off. So the velocity, the linear velocity of
400
the bug is
00.
VA. So half
F is
mv
equal
squared is
to
the kinetic energy of
400
due to the
0
bug
250
jumps at a certain velocity.
and
Then we have the rotational.
H is equal to 0 to 50 0. Now apply the equilibrium equations. First, we need to locate each point with respect to C as follows. So we can write R dc is equal to 300I plus 0J plus 0K mm. R Fc is equal to
Bar.
350I
Now
plus
we see that since the
0J
bar is pivoted
plus
at the one at one
250K
end, so
mm.
IB will be 1/3 MBR squared.
R
So from
Hc is
here
equal to
we'll
minus
equate these two
50I
things before collision and after
plus
collision. And since
250J
this part is 0,
plus
so this
0K
whole
mm.
thing should be equal to L1, which is equal to
Also,
0.
we can
So from
find
there we get
tension
omega
at
B
AH.
equals
TAH
to
will be equivalent to
3
TAH
MA
into
VA
AH vector
divided by
upon magnitude
MBR.
of AH,
So all we did here is we
which gives the
substituted
answer
IB by this expression and then solved for
TAH
omega B. And using the given
0.5
values,
J
we're already given MA,
minus
MBR, and VA.
square
So
root
using the
of
given values,
3
we
by
see
2K.
omega B is 0.12
As we
radians
know
per
also,
second.
sigma MC is equal to
So
sigma R
to
cross
review, omega
F
B is the angular
is equal to
velocity
0.
after the bug jumps
So let's take
from
the
the
cross
pivot,
product
from
of
the
R
bar.
and F, which
So
gives the answer
in part B, we need to find out the
300
kinetic
R d
energy
by K
of the
minus
system.
300 R dz
So
J minus
before
1
the
4
bug jumps, the system was at rest, so the initial kinetic
4
energy
times
was 0,
0K
but the final
plus
kinetic energy will be the kinetic energy due to the bug
1 0
jumping off.
0
So the
0
velocity, the
0
linear
0
velocity of the
I
bug is
minus
VA. So
25
half mv squared is the kinetic
TAH
energy of due
calculation.
to the
What's the
bug
ionization energy of
minus
H2
jumps at a
in
certain velocity.
kilojoules per mole?
Then we
We
have the
look at
rotational
square root
kinetic
H2
of
down
energy.
3T
This is because
So we're
the
going to
bar
do
starts
AH
a very
rotating,
similar
J
thing,
which is
except
half of
instead of using
IB times omega B
2.18, we'll
squared.
use
minus
2.51
And we
since that
already
orbital is
125
lower in
square
energy.
root
we have
of
already shown
3
how to get IB and
Another thing
omega
to note
B.
is that
Well,
we're
we
going to
got
be
omega
ignoring
B
the
is
from the
equal to
previous part.
0.
So if we put all the numbers, we see
As we
that
know, sigma m is equal to
the kinetic
0. So
energy
about each
is
coordinate,
3.2
the
times 10 to the
direction
power
of
minus
each
4
unit
joules.
vector equating to
And in part
0.
C,
So first of all, let's
the
equate the
source
I
of
component
energy
to the
is
0
basically
from
when
the
the
above
bug
equation.
jumps,
So
it
here we
pushes the
need to
bar,
gather all the I components.
and
So in
because
this equation,
it
this
pushes the
is
bar,
the
there
I
is some work
component
done by
of
the bar,
We want
by
to know
the
Z.
bug
we want
on
to
the
know the
system,
energy that we
and
have
This is
to
the I
add
work done
component
is
to
of
being
it
that we
converted
are going to
to the
equate
kinetic
to
energy.
get it
to
to 0.
0, and
So
from
if
that we
the
can
energy
get
of the
the
orbital
result
is -2, then we had to add in
as
2 to get it up to 0.
TAH is equal to
So if we do the exact same calculation as in part A
461.88
with
Newton.
2.51, we see the ionization
By
energy goes up
equating
to
the J
about
component to
1500
0,
now.
we will get the result
Welcome to
Um,
Spring LIB.
And now we want to
Dz
look at the
is
bond
equal to
energy for
minus
We're told that an
H2.
airplane
six-
The
propeller
bond energy is the
has
difference between the energy of the 2
66.667
electrons in the
Newton.
hydrogen atoms
and
and
by
the 2
equating the
electrons
P
when they're in
component, we will
H2.
get the result.
And again,
dy
obviously,
will be
this is the
equivalent to
information in joules per molecule and 1 kilojoules per mole.
505.157
So we need to know the difference here. That's going to be 2.51
just a rigid bar rotating
We know
minus,
so
that
the mass
2.1
moment for that
RD is
112,
equal to
and that's still going to be
squared.
times 10 to the minus
R
18.
dx
And
So
then we
we
want
know
to
that
double
the
plus
that.
initial torque
And we want to double that
D by
because
G
there's
mass
2
moment
electrons
initially,
in here.
so
So
R
each one of those
dz
gets
acceleration
lowered in
is
energy
12
So
by
by
that much.
putting the
initial
values,
torque
we will
over
get
m
RD
squared
as
plugging everything in, we get
50
And now we just do what we've normally been doing. We're going to
0.157G
divide by 1,000
minus
and multiply by 6.022 times 10 raised to the 23rd. That's Avogadro's number.
But also we know the sum of
And we see
forces
the
in
bond
the x
energy is
direction
about
will be 0. So I can write
397.
sigma fx is equal to 0.
So
And
for
by
part
summing
D,
all the forces in
it
the
wants
x
us to look
direction,
up
this is a constant acceleration.
which
the
give the result
answer in
So the final speed is the
RCX is
the
equal
it
to
wants us to
0
look up the
meter.
bond energy for hydrogen.
Similarly, we can take
5.3.
in the y direction.
That
So
bond
Fy
energy
is equal to
plugging
0,
everything into here, we
which
get
leads
final angular velocity
to
is
the RCY is equal to
53.9.
minus
So it gives us an energy of
336.07 Newton.
436.
And
So how's the calculated
similarly,
bond
from the z
energy
direction,
compare?
It's just
Well, it's a bit lower. We got 397 instead.
is always constant.
The percent
RCZ
difference is going to be
is equivalent
for
that we have a constant torque
36
over the whole
minus
That's
397.
466.67
1,000
Newton.
1,950 times.
And then
Now
that would be
also
the
we
difference.
know
And if we
RC
want
is
percent
equal
difference,
to
we have to put that over
RCX
the whole. So that's that
plus
4.
Now they
36
ask
again.
what is the average
RC/G
power
And we get a
plus
percent difference
RCZ
of,
we
is-
we
figure
multiply
out
by
the power,
100 to put
average
into
power.
Now
units
putting
per
the
percent.
values of
About
this
9%
RXY and
difference.
that we can get
to this speed.
minus
How long it
336.097G
took to go through 5 revolutions.
plus
So delta T equals the change
466.6.
in angular
6
velocity
K.
divided by the angular
So
acceleration.
this is my RC.
Welcome to
And that-
Solidify,
and again,
the
this is
place
assuming
where
the
learning
constant.
becomes
This is
simple.
0,
If you're
so we
struggling
wind
with
up
homework,
1.17
assignment, or
seconds.
doubt in
Took
subjects,
1.17
don't worry,
seconds to go
you are in
through
the right
5
place.
revolutions. I'm
So
not
this is
sure
talking
if
again
5
about
was
SP,
specified, but
SP2,
anyway.
and SP3 orbitals.
So now that we know the time it took,
And so we want
say,
to include a
here we
drawing
have
of
the
those
work
orbitals. They're all
that
going to look
was
something
produced,
like this.
The work that was
Welcome to Ask and
Except
Learn.
the only
So
difference
divided
is
by
going to
the
be
time,
sort of the
This is
degree
the
to
problem
which
based work.
and
the
that average
asymmetry
Kinematics
between
of
these two
busybody
orbitals is
here is
exaggerated.
given.
So for
The
SP3,
boom
it's going to be very
But then
exaggerated.
the instant-
For
As shown in the
SP, it
figure,
might be a lot
after it
The
goes
length
through
of boom AB
SP2 would be
is
somewhere
So
like
that means
decreasing
that we have
So essentially,
instantaneous
you know, we can
power
think of
is
an
the
S
torque,
orbital,
which we
completely
know,
symmetric,
At the
a
rate-
P orbital like
value,
this,
and the final
completely
velocity, which
asymmetric.
we know.
And
that's
so the
that.
more
And
degree
plugging all those in, we
P it
get,
has in it, the closer it's going to look
500
to this guy.
105.
0.2 meter
And
per second.
the
So
fewer
when you
P
see a
orbitals it
B,
has, the
bubble
closer
boom
it
is
is.
being lowered at constant rate.
And
It is
And then
lower.
how do we determine if a hybridization
exactly
scheme is
double.
correct?
And
We simply
because
need to add up the
basically
number of atoms and the number of
power
lone electron
starts
pairs
off
in a
at
molecule
rate of
together.
velocity, right?
And then compare that to how many
Assuming
orbitals
the
you've
angular
mixed
velocity
together.
grows linearly.
So, for example,
0.08
if we had something
radian per
like
second.
So
this,
I rounded this
We
off.
have to
So
find
the average is actually half of
A
the
part velocity
at
of
the
point
end.
B as shown in the figure.
we have
Because
no
obviously
lone
the
pairs
power
on carbon.
acceleration of
It's got
point B.
three things around it. So that means we need to have 3 orbitals. That'll be 1 S
I'm
and
just
2
drawing a rough
Ps.
sketch.
So SP2.
This is the boom. Its length is decreasing. This is A point. This is B point. At an instant, its length is 6 meter. This angle is given.
Welcome to Spring
Solidify, the
LIB.
place where learning becomes simple.
So
If
let's
you
see what's
Theta is
given in
equal to
our
30
problem.
degrees.
assignment or doubt in
So
subjects,
we're given
don't
the
worry, you are
radius
in the
r,
right place.
which is
Chapter 7,
2.5
Section
times
Problem 2.
10 to the
Why are
power
scientists
minus 2
concerned about increasing
meter.
Let us see the
atmospheric
solution.
carbon
We
dioxide
can
levels?
convert degree to
And then what's the
radius,
Velocity
source
of-
of this increase?
and that's
It
the
almost
following.
seems like common
So we
sense
have
One
1
side
times
for
10
most
to the
people,
power
and it is
minus
that
6
carbon dioxide
degree,
is
which
an
is equal
important
to
issue
Point
as it relates to both climate
1.74
change,
V
because
dash
carbon
pi
dioxide
times 10 to the power
is a
minus
greenhouse gas.
8.
And
radian.
that term means something very specific.
Then we're given
So we live on
omega
Earth. And,
as
you know, the sun's not black, but
19,200 RPM,
somewhere out in space, we've got
and
the
we can
sun.
convert that
And the light reaches
to
us
radians
through
per
space.
second,
R
and that
into
gives
omega
us
Through the vacuum of space.
2.01
And
times
the green
10 to the
there,
power 3
the atmosphere that we
radians
have
per second.
extends like a halo a little bit
Meter
into
per
And the
second
time
in
is
the
given in
direction.
hours, so 5
down to the
hours
horizontal line.
is equal to
by 60 degree.
1.8 times 10 to the power
And what
4
this
seconds.
does, atmosphere,
Now, since the
A part
is
velocity
traps
of
we can figure out
some of that
the
heat
velocity of
within that
the
atmosphere
velocity by the following equation.
so that we can live and so that our
Plus-
water is
So let's
liquid and
call
all that kind of
omega
stuff.
as
And the way that it
angular
does that is through a
velocity,
couple
which
different
is the
couple
change
different
in
ways, but
angle
one way
phi
is
with
just that
respect to
with
V.
the
by
gaseous
the change in
molecules
time.
in
Substitute
the
the
So
atmosphere,
given
if they
delta phi
get
is
thermally
as
excited because of the UV
1.745
radiation coming from the
times 10
sun,
power
they'll
minus
hold on to
8
that
Take
heat
the
and
x component
radians
of
that
it
allows
and
us to live.
time as
Some chemicals in
1.8
particular
Taking
times
right
10
to
to the
be
allow
power
watch
4
light
here,
seconds,
we
to,
will
which
get
such
gives
as
us
carbon
omega
dioxide, allow light to come
0.48
in really
as
well.
cos of
They're very
60
translucent, but then they
9.4
absorb that
times
that
10 to
light.
the power
cos
minus
And
of 30.
because
So it is to be
we're
equal to
interested
per second.
in having a stable
0.0
climate, is something that we're paying
Now,
attention to.
since
What's the
the
source of
external
this
torque
increase? This
is
is
causing the precision of the
not a
telescope,
debate.
8 meter per
Over the
relate
last
the
200 years
external
since the
torque
Industrial
and y
Revolution,
axis
the precision
humans have
by the following equation.
drastically and
Taking this
exponentially
direction,
increased
omega is
the amount of
tau
carbon
over
dioxide that we put
minus
into our atmosphere due to
0.48
consumption and
where tau is the
combustion
external
of
torque that's
fossil
applied.
fuels.
0.2
There
So
are other
sine
natural
of 30 is
sources
equal to
as
right,
well that do
minus
include
tau
things like forest fires and volcanic
0.5569
activity.
meter
But
per
the vast
second.
majority of carbon
Now
dioxide
magnitude of
comes from
velocity
the
you can draw here.
combustion of fossil
I
This
fuels,
is VV
and the combustion of
times
fossil fuels
little
still
omega,
accounts
where
for the
since
generation
we're
of
considering
about
the
80%
gyroscopes
of
as
our
cylinders,
energy production
so
globally.
I
So
for the
and this
cylinders
will
something
will
to pay
be I,
attention to.
or the
velocity
moment
Good
of
luck
inertia
studying.
for the cylinders will
and
be
this
m
angle
times
is
r
alpha.
times r squared.
First we will find its
So
magnitude,
this
which would
expression
be equal to
becomes
square of
omega
x component
mr squared
Welcome to
0.0668
little omega.
Solarify, the
plus
place where
square of
learning
y
becomes
So
component
simple.
from
If
at
you're
8
there,
pi
if we
square
struggling
root.
with
plug in the
homework,
numbers, we
assignment,
have
or doubt in subjects, don't
9.694
worry,
So
times
you are in the
magnitude
right
of
10
place.
power
velocity
minus
at B
13
point
So the
having
world
the
gets
value
about
per second,
80% of its
and
energy
for mass we
from
have
this
0.2
broad
2
group
kg.
of chemicals we call
520
fossil
meter
For
per
fuels.
radius
second
we
That's
in
have
the
everything
2.5
from
2.5 times
natural
10 power minus
gas
2
to oil
meters
to
squared,
petroleum,
and phi is equal
and
to
then
10
we
just
have the energy of
essentially carbon that's been
2.01
compressed by the
times
earth
10 power
that came from
3.
biomass a long time
Sorry,
ago.
we have the omega as
569 upon
radians per second.
0.0668.
Using all the numbers, we see tau
So it is
is
82 degree
2.4
Welcome to Solarify, the
0.6
place where
times
learning
10 to the
becomes
down
power
to the
simple.
minus
If
horizontal
you're
line.
12
struggling with homework,
Newton
assignment,
meter.
or doubt in subjects, don't worry, you are in the right
Thank you.
place.
Right, so for this question, we're given a molecular orbital calculation for
Now we have
H2,
to find
and
the
what's kind of new about
acceleration.
this is they've actually put in energy
Acceleration
into
of
all the orbitals
concerning
instead of
point
just
AV
having
dash
qualitative
will be
highs and lows. They have actual numbers in there.
omega square r.
So the energy listed in each orbital,
Omega
yeah,
is 6.
is
Welcome
going
to
to
Spring
correspond to the energy of
LIB.
an electron in that orbital.
Solving part A
So
of
the
this
first
R
problem.
part
is
asks
6
us
So
what
omega
using
is the
conservation of angular
energy
momentum
of
here,
hydrogen in
I can
kilojoules
write
per
is
mole.
to be equal to
using
And we just need to look, we don't need this molecular
conservation
orbital
of
picture here. We just want to look at a single hydrogen atom.
conservation
And they give us the
of
ionization energy in terms
angular
of joules
momentum.
per molecule.
Angular
So this is just a unit
So,
conversion.
momentum.
We just take 2.18
I can write a
times
expression
10 to
H.
the negative 18.
LT is equal to
That's in joules. To get it into kilojoules, we'll
LTP
need to divide that
or
by 1,000.
IT
Correct.
And
omega
to get it
T
into
is equal
kilojoules per
to
mole instead of
ITP
kilojoules per
omega
molecule, we'll need
acceleration.
to multiply by Avogadro's
On
rate.
further
So
simplification,
that's
you can write the value of
6.022
omega
times 10
TPH.
raised to the 23rd.
It is equal to
If we do
IT
that,
by
we should get
ITP
an
multiplication
ionization energy of
omega
about
T, which is equal to,
1,313
so this value will be equal
kilojoules per
to
mole.
1 by 2
So based on this calculation, what's the
So
ionization
acceleration
energy
R
of
square
B
by
point will
2
be
in
1 by 2
kilojoules per mole? We look
acceleration
at
of B
R
dash
square
plus
plus
acceleration of
MP
So we're
B
going to
R
with
do
square
respect
a
to
very
both
similar
multiplication
thing, except
omega
instead of
T.
using
twice of
So finally
2.18, we'll
on further
use
simplification, you can
2.51
write the
since that
value of
orbital is
omega
lower in energy.
TP is equal to MT
Another
by
thing to note is that we're going to be
MT
ignoring
plus
these
2
minus signs.
MP
We want to know that
multiplication
we want
omega
to know
T.
the energy
So it
that we
will be
have
equal
to
to
add
120
to
by
component of it
120 plus
to get it
2
to 0.
multiplication
So if
70
the energy of
kg
the orbital
multiplication
is
-3
-2, then we
radian
have
per
to
second.
add in
So you will get the
to
value
get it
as
up
cos
to
of
0.
30.
7 point.
Plus 0 minus
So if we do the
0.0.
exact
Sorry,
same
it is equal
calculation
to
as in part A, so
1.3846
1,
approx
you see the ionization energy goes up to
1.385
about
It is
radian
equal to
per second. Now I will
minus
simplify
Um,
part B
now
of
we
this
want to look
problem.
at the
So in
bond
part B,
energy.
I will use the formula
So the bond energy is the difference
KET
between
is
the
equal
energy of the
and
two
now
electrons
y
it
in
is
the
equal
hydrogen
to
atom
1 by 2
and the two
IT
electrons when they're in
omega T
H2.
square. So it will
And
be equal to
again,
1 by 2
obviously,
multiplication 1 by
this is
2
the
m
equation of
multiplication r square multiplication omega T square, which is equal to
so easy.
1 by 2 m T r square multiplication r square divided 1 by 2 multiplication 1 by 2 multiplication E square multiplication T square, which is equal to 1080. So now I can write the value of kinetic energy, dp kinetic energy, dp is equal to 1 by 2 itp omega tp square, which is equal to 1 by 2 multiplication 1 by 2
double that because there's two electrons. Each one of these is a lower energy now we'll just do what we've been doing. Divide that out and and read and this is all energy is about 200 once this is up,
Together. And then compare that to how many particles
does work. Friction does work. Friction does work. Friction does work. Negative. Friction does work. Negative. Negative work is done by friction. Increasing parachute velocity. Increasing velocity.